All right, let's jump right in. 1.3, simplifying expressions, and there's a little bit of factoring involved in here as well. So let's look at example 1. You'll have one multiple choice question tomorrow, like example 1. Okay. Example 1 is just combining like radical terms, right? Something you've done in the past. If you have something like this, 3x plus 5x, right? We call those like terms because it's 3 of those plus 5 of those. Those just happen to be x's. You combine them and you get 8 of those, right? So that's what we're going to be doing right now, but we're going to be not using x's. We're going to be using radicals. So in this case, we have the square root of 32 plus the square root of 200. We can't combine them the way they are because they're not like radicals. Like radicals would be if it was the square root of the same number. So we have to focus on each of these separately first. So look at 32. Is that a perfect square? No. But does it have a factor that is a perfect square? Yeah, and we saw that one the other day. So if you know what it is right away, you can go straight to the answer, or you could take that intermediate step and just under the radical write 32 as 16 times 2. And of course, then that would on the next line be the square root of 16 times the square root of 2. But you don't have to write that line because what is the square root of 16? 4. So you could just write that as 4 square root of 2. Now notice I work straight down with that first term. Because we're working with an expression, I need to bring down everything on those two lines so that everything's equivalent. Now here's the deal. If you simplify one of the terms first, that's going to inform you possibly as to what the other one will simplify down to, right? More than likely, if this problem is designed to combine like radicals, that other one is going to end up being a square root of 2 also, right? So I could then go straight to the factorization of 200 and call it 2 times what? 100. And you're like, oh, cool. 100 is a perfect square. What is the square root of 100? 10. So I can write that as 10 square root of 2. So notice what I've done there is I've worked with one term, simplified it. That gave me some insight into the other term. But ultimately, at this point, I have 3 lines and they're all equivalent. And now it's go time, right? 4 of those plus 10 of those gives me how many of those? 14 of those. Those just happen to be square roots of 2's. Can one guy be so lucky as to have 14 square root of 2's in his possession? Yep. All right, pretty easy, right? It's fun, it's easy, it's easy. Okay? All right. Real quickly here, let me show you another way to do this, because you're like, I don't know what that plural for is. If you get the prime factorization of a number, and you could do it by factor tree, 200 would be like 2 times 100, right? 100 would be like 2 times 50. 50 would be 2 times 25, and that's 5 times 5. So when you do factor trees, this is your prime factorization, right? What you do then is you look at the root index, and of course if nothing's written there, it's implied to be a 2, right? A square root. That number in the root index tells you how many pairs of like factors on the inside become one of those type of factors on the outside. So pairs. So notice I have a pair of 2's here. So I could bring one of those on the outside. I have a pair of 5's here, so I could bring one of those on the outside. And that's all that I can pair up. What's left? A 2. So he stays on the inside of the square root, and then it becomes 10 square root of 2. So that's another way that you can find simplified radicals if you don't have something like to go on to help you, like the first term there. Okay, so another way to do that. All right, let's try example B. Probably don't have a lot of experience with fifth roots, but it's going to work the same way. So notice as a Q here, I have the fifth root of 3. 3 is already prime, yeah? So I'm not going to be able to simplify that anymore. So there's your Q then, that maybe the first one is going to end up with a fifth root of 3 as well. And so maybe 96 is 3 times something. What would be the other factor? Yeah, 32. Okay, and then I'm just going to bring this one down. So that's the fifth root of 3 times the fifth root of 32. What's the fifth root of 32? 2. We saw that yesterday, right? 2 to the fifth is 32. So the fifth root of 32 is 2. So that becomes 2 fifth root of 3 plus, you can put a 1 there if you want, 1 fifth root of 3. And now 2 of those plus 1 of those gives me 3 of those. And those happen to be fifth roots of 3. So make sure when you write your radical index, it's in that little v of the radical. All right, so here's another way you could have done 96 if you weren't sure. Let's do upside down birthday cake now instead of factor tree. It works very similarly here. It works like this. Okay, 96 is even, so 2 goes into it how many times? 48 times. That's even, so 2 goes into that 24 times, goes into there 12 times, goes into there 6 times, goes into there 3 times, and 3 goes into itself once. So here's the prime factorization of 96 in the upside down birthday cake, right? I guess the candle would be right here, right? Upside down. Okay. So that's a lot of 2s and a 3. How many do I need on the inside to become 1 on the outside? 5. So let's see if I have at least 5 2s. 1, 2, 3, 4, 5. Good. So I have a block of 5. So that's going to become 1 on the outside, and what's left? A 3 on the inside. So that's another way that you can come up with these simplified radicals each and every time. All right? Okay, cool beans. Any questions on simplifying radicals? You'll have one question like that. Think you can handle it? Okay, cool. And it's multiple choice. So remember on the test tomorrow, you can make educated guesses because you're going to have choices A, B, C, D, and E. 5 answer choices. Yes, Ms. Winch, sorry. Sorry. I said Weiss, yeah. From the back, ponytails. Yes, yeah. If there's nothing in the front, it's implied to be a 1. Yeah. Cool. Any other questions? I'll try and get your name right in the dark here. No? Okay. So one question like that. So far, so good so far? All right, moving on. Example 2, I'm not going to have that on the test. Yeah, sweet. Example 3, we're going to come back and do right now. Okay, we'll do this now. Yeah. You're only going to do one like A. So you're not going to have any of these complex fractions on this test. Oh, boy. Or complex fractions like this or like that. You're just going to have one like this. So this is going to be one multiple choice question, and this is where your factoring comes in. Okay? It's like the only place you're going to be factoring. So let's go ahead and take a look at this. This is something divided by something divided by something divided by something. So this is kind of what we did on the quiz, but we're doing it with variables instead of numbers. So what should we do first? Yeah, state, change, flip, right? Keep the first one the same. So I'll go ahead and just write that out. 4y squared minus 9 all over 2y squared plus 9y minus 18. Stay. Change the multiplication. And then we flip. So this becomes y squared plus 5y minus 6 in the top and 2y squared plus y minus 3 in the bottom. So that could be your first step. Stay, change, flip. Now that it's multiplication, we can divide out from high to low any common what? Factors. Good. Not terms, right? Not terms. Only factors. So guess what our next step is? Is anything factored? No. We have term minus term in the bottom, term plus term plus term. So if you look at this right here, you might get disgusted and say, F it, right? And that's exactly what we're going to do. We're going to factor it. Okay? Yeah. Very good. So let's go ahead and factor the numerator. 4y squared minus 9, difference of squares. That's 2y plus 3 times 2y minus 3, right? Those are two conjugates. Now we move to the bottom, and notice there is nothing common there, but there is a 2. So that's prime. So it's going to be a 2y and a 1y. Now 18 has lots of factors. 18, 1, 9 and 2, 6 and 3. So you're either going to have to factor by splitting the middle term off to the side, or realize that these problems are designed to have things divide out, and you can maybe take a cue from something else in the problem that's already factored. Look in the numerator. I've got 2 y's and 3's, right? So maybe this is a 3. We could try it out. Let's put a 3 there and see if it works. If that's a 3, then this other one has to be a what? It has to be a 6. Now let's see if it works. I need to get a positive 9 out. So that would give me a 12 on the outside, a positive 12, and then a minus 3y on the inside. Does that work? 12 minus 3 is 9. Yeah, so it does work. So again, you can use context clues from the problem. Or split the middle term, however you want to do that. We've talked about factoring that. All right, so that takes care of that one. And then times, we'll do the same thing over here. The top one, pretty easy. The leading coefficient is 1. So factors of negative 6 that add up to positive 5. You got to be careful here because it could be the 3-2 combo or the 6-1 combo. They both can give you 6 and 5. Which one is this? It's the 6-1 combo, yeah. And the sum is positive 5, so the 6 has to be positive and the 1 is negative, okay? And again, if you're not sure if it works, please go off to the side, FOIL it out, and make sure you get the right answer, okay? And then the bottom one, again, nothing divides out or factors out. The leading coefficient is not a 1, but it's a prime 2. So again, that's going to be a 2y and a 1y. And then factors of 3. Well, again, that's going to be either a 3, 1 or a 1, 3. If you, again, take clues from other places in the problem, perhaps it's a 3, 1. Let's try it, see if it works. I would need to get a positive 1 here. So that would be maybe a positive 3 on the inside and a minus 2y on the outside. 3y minus 2y is, in fact, positive 1y. So there it is. So that's about the extent of the factoring you're going to have to do on the test tomorrow. Now, once it is completely factored, these essentially can be written now on the same division bar if you want. And now any factor that's on the top and the bottom will divide out to give us what? Things divide out to give us what number? 1, right? So these don't cancel. These divide out. So let's see if that happens. Anything dividing out? 2y plus 3, 2y plus 3. 2y minus 3, 2y minus 3. Y plus 6, y plus 6. And y minus 1, y minus 1. What's left? Good. When you say nothing, that means 0. But we have something left. We're left with 1. Okay? So if this were a test question tomorrow, 1 would be an answer choice, 0 would be an answer choice, and of course some other crazy things if you factor wrong. But I'm not necessarily saying that everything will divide out tomorrow, but let's say that we had 1 factor left in the top, 1 factor left in the bottom. That would be an answer choice, okay? So y'all can handle that, right? Stay, change, flip, factor, divide out. Pretty easy. 1 question like that tomorrow. Okay. Any comments or questions on that? After this test, we'll get back into this type of stuff. Oh, I can hardly wait. And this type of stuff. Oof. All right. Now, number 4 is probably the most important one in this section because this is going to be similar to your free response question. Very, very similar to it. And remember, if you go to the old test page, the link is highlighted at the top of the PreCal page. Go to all the tests that are 1-1 to 1-2 or 1-1 to 1-3. I believe all 3 of those have a free response question that's similar to this, okay? So you could practice those tonight with a timer. You could then score it, see if you got them right, and you can also see how I score it, where I give you points. All right, so this should be review. We'll go over it as slowly as we can. We're on a shortened schedule today because we have advisory. We're in here until 10:25. We're going to stay in 3rd period today for 40 extra minutes and get some of that Rachel's Challenge goodness, okay? Every other Wednesday that happens. 40 minutes. Yeah. 20. We've doubled it, but it's half as often, so it's the same. All right, here we go. If f of x is 3x squared plus 2x minus 4, and another function, h of x, is 5 minus 4x. These are just 2 handsome little polynomials, right? A quadratic, which is a parabola, and a linear function, which is a line. It says to evaluate and simplify the following. Okay, letter A, f of negative 2. How are we going to go about doing that? Plug it in. Now, I'm going to tell you how to plug things in. Maybe it's different from what you've been doing, but I promise that if you do it this way every time, you will avoid careless mistakes later on. Because we're going to be plugging in things other than just plain old numbers. We're going to be plugging in functions of x. So that x is just a placeholder for some input, right? F of input equals 3 input squared plus 2 input minus 4. Our input happens to be negative 2, but here's how I would suggest you do it. Below f of negative 2, you don't need equal signs. You can just put 3 parentheses squared plus 2 parentheses minus 4. What did I essentially do? I went backwards a step from algebra. I actually replaced the variable, which stands in for a number, with a blank, a space, okay? And now, whatever is in here, whether it's a number, a purple horseshoe, or an expression like holy moly, you can plug it in to those green parentheses, all right? So I'm going to plug in a negative 2 and a negative 2. It seems kind of like too much for this problem, but if you do that every time when we have bigger things to fry, bigger fish to fry, you'll get it right, okay? Because if you don't set it up right, you're not going to get the right answer. Okay, now we just have to simplify. So do we multiply these first, or do we do the exponent? Exponent, right? Your dear Aunt Sally. So negative 2 squared is positive 4. Yeah. Times 3 is 12. 2 times negative 2 is negative 4 minus 4. All right, so from there you can get your answer. If you want to do it still in a baby steps, that's 8 minus 4. The answer is 4. So tomorrow in the test, because this one's pretty easy, that's probably going to be worth 1 check. So that problem right there is equivalent to essentially 1 multiple choice question. All right? So that number could be anything tomorrow. And this right here, the only difference on tomorrow's test, it might be like 4x squared minus 3x plus 7. It'll be a different quadratic. And you'll be plugging in a different number. But it's pretty much the same idea. Pretty easy, right? Algebra 1 type stuff. All right, letter B. We read this as h of f of x, not h times. Okay, another way to write this is h of f of x. You might remember in algebra you had like fog of x. Remember that? Fog of x? That was not fog, right? That was f of g of x. So those both say the exact same thing. The top version is the condensed version. Mathematicians like to have 2 different versions. The condensed version that we can kind of condense down and use to travel with on airplanes or to put it in a space bag under our bed when it's out of season. And then we have the bottom one, which we call the expanded version, which is the one we like to have when we're going to be using it. And we are going to be using it. So what does this mean? This means just like over here where we plug the negative 2 into the function f, we're going to be plugging the function f into which function? H, right? This is composition. That's what this is called. This is called composition. We're plugging one function into another. So we could start the same way. We could take the h of x function, which is 5 minus 4, and in place of x, I'm going to put parentheses. And now what am I going to plug in the parentheses? Not a negative 2, but f of x. So you can either put the name f of x in there and go to another line, or let's just go ahead and put what f of x is equal to in there. It's going to be 3x squared plus 2x minus 4. Okay? We're plugging a function in for x instead of a number. And so here the parentheses are super important, because without the parentheses, you're not distributing the negative 4. So again, if you set up your parentheses first for x, plug in second, you'll set it up right every time. And if you don't set it up right, very likely you're not going to get the right answer. All right, what do we do from here to simplify? Distribute, right. We're just going to expand everything out. So remember, you're distributing a negative 4, so that changes all the signs. So minus 8x and then plus 16. And then what we do for our final answers, we collect like terms and we write it in descending order. So start with your largest power of x. There's only one term. And then you've got your linear term, which is 8x, negative 8x to the first. And then you got your numbers, plus 5 plus 16 is plus 21. Okay? And there's your final answer. So you'll have one like that tomorrow on the test, and that's probably another 1 checker. Okay? Because that one is still relatively not difficult. Okay? Parentheses for x first, plug in step 2. 2-step process. Okay? Any comments or questions on that one? Palatable? So far, so good? Okay. Letter C. Fohax. 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 What does the fohax say? What is that? How do we say that? F of h of x. Good. So this is a condensed version. So what should we do first? It's going to make a little more sense if we write it in the other version. It's not required, but I would help myself. So that's f of, parentheses, and then I'm going to write h of x just kind of a little bit smaller there. So the top one's condensed, easy to travel, easy to store. The bottom one's expanded, easier to use. Because now you can physically see that you're going to plug in for x into the function f, the other function, h of x. So this one is almost identical to example A, except we're not plugging in a negative 2. We're going to be plugging in the function h of x. So we're going to start the same way. Underneath here, because it's the function f on the outside, we're going to say it's 3x squared, but I'm putting parentheses in place of x, plus 2x, again, parentheses in place of x, and then minus 4. Okay, and now what am I plugging in for x? H of x, yeah, which is 5 minus 4x. So 5 minus 4x, 5 minus 4x. This one on the test tomorrow, I might give you a separate check just for the setup, because it's a little bit more challenging. There's 2 places to plug in. So 1 check for the setup. Okay, now there's still a lot of algebra to go, so you'd have another check for the right answer. You could still, at this point, make careless mistakes on the way to the final answer, in which case you've already banked the first point for the setup. If you're missing parentheses here or something, you're not going to get the setup check, and you're not going to get the answer check. All right, so this first term we have to simplify. Do we multiply the 3 in first or square it first? Square it. Good. Now, do we just kind of give the 2 to each of those terms? No, we talked about that. Those are terms. So this is foiling, and if you want to go off to the side, you write them side by side. Off to the side, 5 minus 4x, 5 minus 4x. Okay? If you want to do it off to the side. First outer inner last, you're going to get a 25, and then you're going to get a minus 20x, and then another minus 20x on the outside, and then be careful on the last. The negative times the negative is a positive, so you get positive 16x squared. Now, if you want to write this in descending order, that's up to you. I'm just going to go ahead and write it as 25 minus 40x plus 16x squared. So that's one way to do it. Here's another way to square a binomial, and I'll say it one time. If you're not comfortable with it now, just spoil it tomorrow. But when you're squaring a binomial, the way to expand it quickly in your head is to do the following. Square, multiply double, and then square again. Square, multiply double, square. Square, multiply double, square. Okay, what do I mean by that? Square the first. What's 5 squared? 25. Okay? To get the middle term, you multiply these two. What do you get when you multiply those two? Negative 20x. Double that, negative 40x. So square, multiply double, and then to get the last one, you square the last one. What do you get when you get negative 4x quantity squared? Positive 16x squared. So if you want to do that, I don't know if you've heard that before, but it's a time saver. Square, multiply double, square. Square, multiply double, square. Square, multiply double, square. If not, just go off to the side. Stack, multiply, FOIL it, whatever you want to do. Okay? Tomorrow, I just want you to get the right answer. We'll develop all these shortcut strategies later on. Okay, so the 3 is still there. And we're going to have 25 minus 40x plus 16x squared. All right, now on the next one, I'm going to distribute the 2, so I get plus 10 minus 8x, and then I just bring down the minus 4, right? So now I can distribute the 3, correct? 3, dun, 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 so I get 75 minus 120x plus 48x squared. And if you want, on these 3 terms that are left, you can combine things as you go if you want. 10 minus 4, it's going to be positive 6, and then we're left with the minus 8x. All right, so once it's completely expanded out and it's done correctly, you should get the right answer, because now it's just a matter of combining like terms and writing it in descending order. So we've got an x squared term there of 48x squared. My next terms are my x terms. I'll single underline them. So that's going to be minus 128x. And the ones that aren't underlined are my numbers, positive 75, positive 6. That gives me a positive 81. And you'll get another check for your final answer. Okay, so on tomorrow's test, you will have one like this. You'll have different numbers, but you'll have a quadratic function and a linear function. So it's pretty much the exact same technique with different numbers. And you'll get 2 checks for that. So that counts as like 2 multiple choice questions right there. One for the setup, and then one for implementing the algebra correctly to your final answer. Y'all could do that, right? Nothing to it. Comments or questions on that? A, B, C, D comes next. All right. H of F, what? What is that? F squared. Yeah. So again, this is another condensed notation. Let me make this note up here. If you ever see like F squared of X, that's condensed notation. The expanded version would be the function F of X quantity squared. We write it like that. Okay? So what we're squaring is actually the output, the Y value, not the input. All right? So the left side is condensed, the right side is expanded. So my first recommendation to you is to rewrite it in expanded form. So that's H of, and then I'm going to write that as F of negative 1 squared, and then close. All right? So now I have something to do. I can work from the inside out. My first thing I need to do is I need to compute F of negative 1. If you want to do that like we did on part A, I would recommend doing that off to the side. Now, tomorrow you're going to have the paper in front of you. On the iPad, sometimes we get tunnel vision. So I'm going to go ahead and do that over here off to the side. I'm going to go ahead and just evaluate F of negative 1. So again, that's 3 blob squared plus 2 blob minus 4. And then I'm going to plug a negative 1 into those parentheses. And now I carefully simplify that, and I get 3 minus 2 minus 4, which is negative 3. Okay, so if you want to do that off to the side, that's great. And then you could take that negative 3, and now we're physically going to replace it, right? So there's a negative 3. And notice I'll highlight what I just did. Okay, so that was just a calculation of f of negative 1. What that does is it makes the problem easier when you're working straight down. You don't have all of those terms in there, right? You do it off to the side, bring it back in. Bench work, right? Now we do negative 3 squared. Brackets here, or the brackets act just like parentheses at this point. So what is negative 3 squared? Positive 9, all right? And so really what this problem comes down to is, what is h of 9? Well, h is 5 minus 4 input. So this is going to be 5 minus 4 parentheses, and in those parentheses we're going to be plugging the 9. And now what do we do? 5 minus 4 first? Nope, multiplication before addition. So we get 5 minus 36, and you end up with negative 31. So a question like this tomorrow, if it showed up, something similar to this would be another 2-checker. Probably one for your setup, maybe getting all the way to the 9, and then one for evaluating it after that. Okay, so you can earn intermediate steps. If you make careless mistakes late in the game, you can still bank points early. I grade your process on the free response, which is why it's so important to show all of your steps in a nice way. Now, I'm probably not going to be real strict with your notation tomorrow, but hopefully you're practicing it like this, because on subsequent tests, the notation will be part of it, okay? All right, this one here, let's just do this one very quickly. That's h squared of x. That's condensed notation. So that turns into h of x, the entire function squared. So in this case, we're not plugging anything for x. We're just going to take the h function, which remember is 5 minus 4x from up above, and we're squaring it. All right, so in this case, we would just FOIL it. The brackets act just like parentheses. Have we already done that today? Yeah, we've already done that. So if this was a brand new problem, you would go off to the side and do that. Today, I'm just going to kind of import this answer or copy it and paste it. Okay, so just wanted to give you another problem that had that condensed notation with the squared. So there would be your answer. All right, piece cake. First outer, inner last. Do it off to the side. All right, 2 problems left to go. And the last one's my favorite. This one is h of h of h of x. h of h of h of x. So we're plugging one function, first of all, into itself, right? And then we're taking that result and plugging it back into itself. So this one is very meta, right? Kind of like Inception. Plug it into itself. It's like looking at that picture on the wall, and in that picture there's a guy looking at that picture on the wall, which in that picture it has a picture of the guy looking in that picture, and it goes on forever and ever, right? That's kind of what this one is. So to do this one, what I would do is maybe kind of just work with this first, maybe off to the side. Let's focus on h of x. Work from the inside out. We know how to do h of x, right? So let's do that off to the side. That means that we're going to take the h function, and inside of it for x, we're going to plug not a 2, not a negative 1, but the function itself. So working with the outside piece, which is h of parentheses, looking at the function above, it's 5 minus 4x, right? That's the green part. But in place of x, I'm putting parentheses. And now what am I plugging into those parentheses? H of x, yeah, which is 5 minus 4x. So there it is. You're plugging a function into itself. 5 minus 4 blob, and the blob is 5 minus 4x. Okay, so now let's simplify that by distributing 5 minus 20 and then plus 16x. If you simplify that, you get 16x minus 15. So notice I did do this off to the side. Now what can I do? I could take this result and replace it with that. Okay, so now working straight down underneath that, that now becomes h of 16x minus 15. Inch by inch, it's a cinch. So I have to do this one more time. And so underneath there, I will have 5 minus 4 parentheses. But what am I plugging into the parentheses? 16 minus, or 16x minus 15. Yeah. Inch by inch, it's a cinch. So there's the highlighted correspondence, okay? And so one last time we distribute, we get 5 minus, that's 64x. And don't forget, when you distribute a negative, you change the sign. That's a common mistake, plus 60. So in descending order, that's now negative 64x, and then plus 65. So for a problem like this, you would for sure get at least 2 checks, maybe even 3, but for sure at least 2. Off to the side, bench work, component work, bring it back into the main problem. And again, if you work straight down, you don't even need equal signs. All right, so far so good. Any questions? All right, so the next problem is my favorite problem. And you'll see this one on probably the first 3 tests of the year. Now, I'm going to change the letter here because it was kind of confusing. I had an H there before, and H is inadvertently what I call this function. I don't want there to be any confusion. So I changed it to a P. So if you want to change yours to a P as well, that letter could be anything. It could be a P, a Z, something that's different, though, from F and H, okay? So this problem is very important because this has calculus implications if you go on to take calculus. All right, so working through the algebra part now, you'll be ready to go if you go on to take calculus at any point in your lifetime, okay? So what we have to do first is set up this expression. And if you notice what we have here is we have in the numerator 2 terms. The first term is f of x plus p, which is similar to what we've been doing. The second term in the numerator is just f of x itself. And then p is just some random variable. It has nothing to do with either of the 2 functions f or h. So what I have to do first is set this up. So let's focus then on this first term in the numerator. Like if this were its own problem, f of x plus p, how would we set it up? It would be 3x squared, but I'm putting parentheses in place of x, plus 2x, but I'm putting parentheses in place of x, and then minus 4. Yes? Okay, good. Let me highlight that to point it out. All right, so now all I have to do in the parentheses is plug in a what? An x plus p and an x plus p. Okay, so that takes care of that first term in the numerator. Done. All right, so now I move on to the second part, which I have to be a little bit more careful with. Now it's minus f of x. So it's minus. Now here's where you want to be very careful. Anytime you write a minus sign, you need to be very careful about what follows, because if what follows has more than one term, you're going to have to distribute. So what I would recommend here is a parentheses or a bracket or something, okay? And now all I'm going to do is plug in f of x there. So that's just 3x squared plus 2x minus 4, and then I'll close that parenthesis. That's just f of x itself. We're plugging x in for x, okay? So that is this piece. Okay, so the highlighted corresponds. And now it's all over just little old p. So tomorrow on the test, that little p could be an h, it could be a z, it could be a q. It's going to be something that's different from the name of the 2 functions, okay? If you want, you could put parentheses around this first setup as well up here, just to kind of show the association. But it's not needed there. It is needed here. And that is a common error. I will tell you that about half the students every year when they set this up on their free response, because you will have one like this, they forget those parentheses right there, which means they never on the next step distribute the negative, and they get it wrong. Because at this point, you've earned 2 checks already. I'm going to give you 1 check for that. I'm going to give you 1 check for that. If you're missing the parentheses, you're going to lose that check and probably the answer check. Okay, any questions on how to set that up? Super important. Once we set it up, now it's just a matter of routine algebra. We're going to have to expand it out completely like we've done on all the other problems. So let's look at that first term. I have an x plus p squared. So again, off to the side, if you just want to do x plus p times x plus p, you FOIL it out, and you're going to get x squared plus 2xp plus p squared. I kind of skipped that middle step. That's square, multiply double, square, okay? So bringing that in, I get 3 parentheses x squared plus 2xp plus p squared. Don't forget the 2, okay? Because when you do inner and outer, you get xp plus xp. All right, and the next one, I'll just distribute that 2, and I get plus 2x plus 2p, and then I get minus 4. So that is me just expanding partially that first term in the numerator. All right, now the next part. This part is critical because if you have the parentheses, you're going to be fine. If not, the problem's not going to work for you. Distributing the negative, you get minus 3x squared, but more importantly now, you get a minus 2x and a plus 4. It changes those last 2 signs. And if you don't have those parentheses there, you're probably going to have the minus 3x squared, but you're still going to have a plus 2 and a minus 4. Okay? All of that is still over P. So remember, as you work down, every line needs to be equivalent to above and below. So if you leave off that over P, eventually you're going to lose a point. I might be a little more lenient tomorrow. Just practice properly. Okay, one last step here. I need to now distribute this 3. So 3x squared plus 6xp plus 3p squared. This is just a lot of work. It's not this difficult work. So just do it very carefully, do it very meticulously. So once you expand that, you are free, if you want, to combine anything else that happens to cancel. Does anything else cancel? Let's focus on there. Yeah. If you do it correctly, things should cancel. This is a plus 2x, and that's a minus 2x. But you know what's going to happen if you didn't distribute that negative? You're going to have a 2x plus 2x. You're going to end up with a 4x instead of a 0. Okay? What about the negative 4s and the positive 4s? They also cancel. And if you didn't distribute, you're going to end up with a minus 8 instead of a 0. So when you set it up correctly and you distribute correctly, things should cancel. So all that leaves then is the plus 2p and the minus 3x squared. Okay? And that's still all over p. And now since I have the first part fully expanded, look to see if anything else cancels. Anything else canceling? 3x squareds, which again, if you did not, well, you probably get that one canceling because it was in the front. Okay, so here's how this problem will always work, which is why it's so cool, why I like it. Everything that's left is a different term. You have an xp variable, a p squared variable, and a p variable. So they're not like terms, so you can't combine them. But you notice they all have what in common? They all have at least a p in common, and that will always be the case. Whatever that variable is in the denominator, what is left should all have that variable in it. And everything else that doesn't have that variable should cancel. Okay? It will always work that way. Which means, in this case, we can factor out the p from the top. So that leaves us 6x plus, we're still left with 1p from a p squared and plus a 2. And I do want to see that step of factoring it out. Factor out the p in the top from every term, and now it's divided by p. And now what happens with those two p's? They don't cancel, they divide out to give you 1. Yeah, it's different, right? Things cancel to give you 0. Things divide out to give you 1. I wish your other teachers had emphasized that, but a lot of math teachers say those cancel. That's not right. Okay? So what does that leave us with? That leaves us with 6x plus 3p plus 2. And as ugly as that looks, that is the answer. Okay? And you're going to get a final check for getting to the finish line on that one. So pretty generous here. 1 check for each term on the setup, and then 1 for all the rest of the algebra. But I promise you, tomorrow you will have another quadratic. It's just going to have different numbers. It might be x plus h or x plus z, but you're going to set it up, expand it, cancel, factor, divide out the exact same way. What's the important thing? Set up each term separately. Okay? You want to know what the most common mistake is when I have people set up f of x plus p? You want to know what the most common mistake is? They go like this. They say, okay, that's f of x plus p. So that's going to be 3x squared plus 2x minus 4. That's f of x. Oh, and you want plus p? So plus p. Is that the same thing? No. That's the quantity f of x plus p. We want f of the quantity x plus p. We want to plug x plus p in for x, not just add a p at the end. So if you're doing that, you're doing it wrong, okay? So how can you prevent that? Do what I said. Replace x first with parentheses. Yeah. And then whatever's in the parentheses up above, you plug it in there. If you don't get the setup, you're not going to get the answer. So this could cost you 2 checks instead of just 1. And then, of course, tomorrow on that second one, after the negative, what do we need? Parentheses, okay? Parentheses. Now, later on, you might get so awesome that as you're writing it down, you write this down immediately. You distribute in your head. That's great, okay? I don't know if you're there yet. I wouldn't recommend trying that just yet. You got to get a little bit more practice in, a little bit more fluid. Okay, so that's it. That's all that we're going to test over tomorrow. You're going to have no calculator available on the test, but you won't need one, okay? You're going to have the entire 50 minutes. So Come in tomorrow ready to go. You're going to need a pencil, and you're going to need blank scratch paper, which I will have on that table over there. I'm going to have colored paper over there. I may just hand it to you at the door when you come in. That you have to turn back in, okay, for security reasons. And remember the honor code. You're going to have 7 multiple choice questions more than likely, and then 1 free response question, like example 4, and it's going to be approximately 7 or 8 checks. So roughly about 50% for each section. Where can you go to practice besides worksheets? Practice tests. Yeah. Practice tests. So just to remind you, because some people are like, where is that again? If you go to the PreCal page at the top, it's that yellow link, right? Links to old tests here. And again, if you work any of those first 3, 1.1 to 1.2, 2015, 1.1 to 1.3, there's 2 of them. Yes. So again, let me show you what I mean. If I download the 2017 test, that's last year, look at the free response. There's a quadratic. There's a line. What's f of -2? What's f of g of x? What's g of f of 3? And then my favorite problem that we just did. That's it. That's the free response. Can you handle that? If you know exactly what the free response is going to be, and you know that that's going to be 50% of your grade, I would not walk into class tomorrow not knowing how to do a problem like this, okay? Because that would just be foolish, right? That would be not doing this enough, right? Caring, yeah. Okay, so next period is third period. It's going to be shortened again, but then you're going to stay in there for 40 minutes, and you're going to have your first advisory Rachel's Challenge class of the year. So anyway, I will be back here in the morning at 8 o'clock. I have duty after school today in a faculty meeting. So back here in the morning.